Okay, so we've got this equation. It's a first order equation. The way it's written, it doesn't look like a linear equation, but it actually is a linear equation. I'm going to solve this using two different methods. On the left-hand side, I'm going to solve it as if it were a separable equation, since it is. And on the right-hand side, I'm going to solve it as if it were a linear equation, since it is. Okay, so separable equation means you can move all of the x stuff to the left-hand side, or with the dx dt, and everything else on the other side. Okay, so at first, method 1, separable. Okay, and at first, both methods you're going to have to rewrite it. In this method, we're going to rewrite this as 1 over x plus 1 dx dt equals 2t over 1 plus t squared. Now remember a little bit of theory with the separable equations. The left-hand side for this method, what we're saying, the left-hand side, if you have a function, f is a function of x and x is a function of t, the left-hand side is the derivative of f with respect to t by the chain rule, because remember the derivative of f with respect to t is equal to df dx times dx dt. That's just the chain rule. Okay, and so basically we want to find some function of x, we want to find some function of x whose derivative is equal to 1 over x plus 1. Okay, I'll let you think about that for a moment. Pause it if you want to, but that's the natural log of x plus 1. And so what we're saying is that the left-hand side is the derivative with respect to t, let me just write this explicitly, of the antiderivative of dx over x plus 1. And this is equal to 2t over 1 plus t squared. Okay, but this is just the derivative with respect to t. The antiderivative of this is the natural log of the absolute value of x plus 1. Okay, notice technically we should be adding a plus c, but the derivative of a constant is just equal to 0. So these two expressions are equal to each other, and we're just going to write this as 2t over 1 plus t squared. We're going to take the antiderivative of both sides with respect to t, so the left-hand side, by the fundamental theorem of calculus, we just get the natural log of x plus 1. And on the right-hand side, well, we're going to take the antiderivative with respect to t. This is a great u sub problem where u is going to be equal to 1 plus t squared. And so the antiderivative here is a natural log of 1 plus t squared. Technically, we need absolute value signs, but remember, 1 plus t squared is never negative, so we don't have to do that. And we'll add the plus c. And notice there should have been a plus c here as well, but we're just going to add that plus c to the right-hand side like that. This is a very standard thing that we've been doing in this class. Okay, so next what we're going to do is we want to solve for x, so we're going to raise both sides to the power of e, and on the right-hand side, really what we get is the absolute value of x plus 1 is equal, okay, on the right-hand side, we get the absolute value of x plus 1 on the left-hand side. On the right-hand side, we're going to get some constant, e to the power of c times 1 plus t squared, okay, but e to the power of c is just an arbitrary constant, so we always like to write that as another arbitrary constant, 1 plus t squared. You could have kept it as, c times 1 plus t squared, that's fine. Okay, but now notice the absolute value. We want to get rid of the absolute value, but notice the absolute value is just multiplying x plus 1 by plus or minus 1, and that's also an arbitrary constant that can be absorbed into the a, and so we're just going to write it as this. And finally, we get that x of t is equal to a times 1 plus t squared minus 1. Okay, so let me show you like a separation of variables method that most of y'all like to use, which is fine, but it's technically kind of an illegal operation. But it's this thing where you actually, instead of putting, so you kind of go one step further, and you're going to put this t on the left-hand or on the right-hand side of the equation as well. And so what you end up with is dx over 1 plus x is equal to 2t over 1 plus t squared dt. And now we just say, well, we'll take the antiderivative of both sides, And on the right-hand side, you're going to get the natural log of the absolute value of 1 plus x. And on the right-hand side, you're going to get the natural log of the absolute value of 1 plus t squared, okay, plus a constant. And that puts us right back in this situation here, okay? And now we'll just solve for x like we did above, okay? So the way that I did in gold is perfectly fine, but it involves this thing where we're multiplying both sides by dt, which means we're treating the dx dt like a fraction, which is not something that we really, it's sort of an illegal operation. It's a good heuristic, which is why I mentioned it, but I really prefer the way I did it at first. But this is going to be a multiple choice. This is a multiple choice question on the test, so do it whatever way you want. Okay, so now I want to do this as a linear equation. Remember, a linear equation has the form dx dt plus some function of t x is equal to some other function. Okay, and it could be that there's a function here as well, but we can just divide both sides by that function and kind of put it in a standard form like this. Okay, so anyways, I can rewrite this equation in the following way as dx dt minus 2t over 1 plus t squared x is equal to 2t over 1 plus t squared. Okay, so this is a first order linear differential equation. That means this is a great integrating factors problem question. And so mu of t is going to be e to the power of the antiderivative of the coefficient on x, which usually we call p, but I called q for whatever reason. So it's going to be the antiderivative of minus 2t over 1 plus t squared dt. Okay, so the antiderivative here, this is e to the power, so the antiderivative of minus 2t over 1 plus t squared is minus the natural log of 1 plus t squared. Okay, so notice this kind of penultimate step of taking the antiderivative of that of the 2t over 1 plus t squared. You have to do that in either method. Okay, and so by rules of logarithms, this is equal to e to the power of the natural log of 1 over 1 plus t squared, and so this is just equal to 1 over 1 plus t squared. So the integrating factor is 1 over 1 plus t squared. I'm going to multiply both sides by the integrating factor. This is what you get on the left hand, or on the left hand side. On the right sides of the equation, by the integrating factor, the right hand side becomes 2t over 1 plus t squared squared. We'll take the antiderivative of both sides. On the left hand side, you get x of t times 1 over 1 plus t squared. Okay, on the right hand side, this, again, let's just do this in our heads, and if you need to write this out on some scratch paper, that's fine, but this is just the antiderivative of the right hand side with respect to t. We're going to say u is equal to 1 plus t squared, so then du is going to be equal to 2t, and so we're taking the antiderivative of u to the minus 2 with respect to u. Okay, the antiderivative of u to the minus 2 with respect to u is minus u to the minus 1, so this is going to be equal to minus 1 over u, which is 1 plus t squared plus c. Okay, so now I want to solve for x, and we get x of t is equal to minus 1 plus c times 1 plus t squared. And notice both methods give the same solution, which is good because there's this uniqueness theorem that says every initial value problem has a unique solution. So it's good that we're getting the same solution with both methods. Okay, so this was just me doing this problem with 1.5 to 2 methods, depending on how many, I kind of did it separable twice. Any one of these is perfectly fine for the test. The linear integrating factors problem involved kind of two, not difficult, but two kind of integrations where we had to use u sub or something like that. So maybe separable equation would be the best one to do it, but neither one of them took that long, so either one is fine.